Okay, so give the atomic numbers for each of the following elements using a periodic table. My periodic table over there. So this one, carbon is 6, and then this one is iron. Iron is 26, and this one is bromine. Bromine is 35. It shows right there in the corner. And then mass is equal to the number of protons plus neutrons. And then for this one, protons is 17 there. That's protons still on the bottom right there. Also, if you look over here at the periodic table, it tells you right there as well. And then neutrons, you can find it by taking the mass, minus the atomic number. That's 18. Electrons, 17. And then the mass number is 35. Again, you can find that right there. Charge is 0 because electrons and protons are the same. And then protons right here is 30. Again, you can find that from the periodic table. That one is zinc. Let me see where zinc is. Zn right here, 30. And then I took mass minus atomic number, 34. Electrons is 28. So which means that it has less electrons. So it's 2 less. So which means it has a positive charge of 2. And then the atomic mass number is 64. How I found out is right there, and then 2 also tells me that it's a positive charge. And this one I worked backwards, so I looked and I saw neutrons 34, okay? And then but I knew that it had a positive charge of 3, which means that it lost electrons. So then I added 3, which is how I found the proton. Then I found that it's what do you call this? Like gallium. And then so then I knew I put the positive charge at the end, which because that's what we do, just like that one. And I also put the proton number right there on the corner of the side. And the atomic number is 69. Which again you can find right here at the periodic table. I did the same thing with selenium. It gave me the proton 34, so that's how I found out the selenium, because I looked at the periodic table. It has a negative charge of 2, which means it has extra electrons, and that matches up right here, 36 neutrons, which means that it has extra mass per se, which is why the mass number is 79. And go back and look at, where is it? Selenium. It's only by a little bit because selenium is 78. And then for this one, calculate the atomic mass. So I use the formula where I take mass of one of the isotope times the abundance, and I change that into a percentage by dividing it by 100. Doing that, and then I added them, which is got 6.94, and then I can check myself by looking back at lithium right here, which is, what is it, 6.94, so I got that. And then let's see, going to the back, for this one says when naming iconic compounds. So I just wrote myself a little note. Iconic compounds mean that the elements either give or take electrons, and then ionic means it's a metal plus a non-metal plus ide. For this one, give 10 examples of ionic compounds. So I did iron 3 chloride. Since I put iron, I put the symbol +3 right there. And again, you can check yourself by going here to the periodic table. Look for Fe. Where's my Fe? goodness, I'm blind. Where's Fe? Fe? Why am I so blind? Fe. I know I'm not blind. Where is it? Oh, here it is. Fe, right there. Fe. Fe, and then plus 3, and then chloride or chlorine, I guess. Chlorine has a -3, and then I take out the the thing up here, and so because we don't do that at the final answer, so that's why I got Fe3Cl3. And then this was sodium fluoride, sodium Na +1, and then a fluorine +1, but it becomes ide because it's an anion. And then sodium is still the same because that's the rule, because it's a cation. And then I check myself, like I do like +1, -1, make sure they're balanced, because you have to balance them. So then it's Na and then F, and I don't have to put like the 1 or anything because it's pretty much like known. And then this is my third one, zinc oxide, zinc +2, and then oxygen is -2. And then you can, because you look at the table, this is in the group -2, and then zinc. Where did I put my zinc? Zinc is right there. But then you have to do like the two, like where you would cross. What is it like basically like like this, and then O, and then let's see, if O2, you'd have to like cross, like yeah, that's okay. That's you get what I'm saying, yeah. Okay, and then silver bromide, Ag +1, bromine becomes bromide, -1. It's already balanced, I don't have to worry, so it's AgBr. Silver oxide, so this one is Ag. Technically, it was Ag1, and then oxygen has a negative because it's in the group 2 right here, which is what I was trying to explain earlier, because you have to balance them and whatnot. So then it becomes Ag2O, because silver is just, silver is just I guess I'm losing track of my thoughts. Yeah, it's because Ag silver is +1, so that's why there's 2 of silver and just 1 of oxygen, because oxygen is -2 for 1 atom of oxygen, and silver, it is only 1 negative, so you need 2 of the silvers to balance out. Sorry for the rambling. Silver fluoride, it was originally fluorine, drop the ene at the ide because it's a non-metal at the end right here, and then Ag +1, and then fluorine fluoride, whatever, is a -1, and they're balanced, so you don't have to do anything. So it's just AgF, but the end name is silver fluoride, just so you know that I know. And then calcium oxide, Ca +2, and then oxygen is -2. It balances out, so it's just CaO. Barium sulfide, Ba +2, and then oxygen -2, again balances out. And then the lithium fluoride balances out, +1 -1 balances out. Magnesium fluoride magnesium right there is what is it, +2 for 1 atom of magnesium. Fluorine or fluoride in this case is only -1, which is, and if you go back to your periodic table, you can see right here -1 is in the -1 group. So you need 2 pieces of fluoride or fluorine to balance out. So it's MgF2. And then for this one, what is it? This is non-metal plus non-metal. You have to follow the prefix rule before both elements. And I just writing that so that I don't ramble even longer. So then carbon monoxide right there. It's just one. Carbon dioxide. You see right there, CO2. Carbon trioxide, CO3. So you see how you add the prefix to that. And then nitrogen monoxide, NO, nitrogen dioxide, NO2. See, so then there's a 2, that's why you need the di. And then nitrogen trioxide makes sense right there. See, you see di right there, and then tri right there. And then you, for the other ones where it's just 1, you could put 1 if you want to, but you don't have to. But if it's anything more than 1, then you have to add the prefixes. This one right here is phos. Oh wait, no. Okay. No, wait, is that? Yeah. Yeah. Okay. Yeah. I'm sorry. I'm like over the place in my worksheet. So sorry. All right. So this one is phosphorus monoxide, PO. Again, 1 oxygen, so it's just mono. Phosphorus dioxide, PO2, dioxide. Diphosphorus tetroside. So you see why I put di because there's 2 phosphorus, and then oxide, there's a 4 right here, so then that's why it's tetro. And then when there's oxide, you drop the A and you just make it an O. And then tetraphosphorus decoside, P4O10. See, so instead of deca oxide, which would be wrong, it's decoside or decoxide. We have tetraphosphorus decoside, 4 tetra deco 10. Alright, so this one is a little confusing. So this is it right here. So for the give 10 examples of binary acids right here with the rule where you have to do hydro plus non-metal and ic acid. So the instructions were a little confusing, so I wasn't sure if you wanted like 10, 5, 5 for a total of 20, or if you wanted like just 10 overall where it's like 5 this and then like 5 that, or like you know, like a mixture where I could have some hydro ones in there. So I just went ahead and did just did 20 to be on the safe side. So this is for the X. So this was hydrochloric acid, and then yeah, I include like the plus and minus, like negative, just to kind of help me out in the beginning. So you see right here, because the hydro +1, that's why I did that. And then chloride is a -1, because again, if you go back and you look at the group, -1. So then, but you drop those positives when you get to like the end of the formula, which is where I squared them or circled them off. This one is hydrobromic acid. Yeah, you see, so hydrogen positive, bromine negative, HBr, drop those positive negatives. Again, hydrofluoric acid, sorry for the smear, becomes just HF. Hydroiodic, sorry, I don't know how to say, hydroiodic acid becomes just HI. And then hydroxyic acid, H2O, which is water. So yeah, And then hydrosulfuric acid, H2S. And then this one is hydronitric acid, HN3. I just kind of dropped out the middle part instead of like, going back and forth of doing like the plus and minus. I just figured I already did it kind of in the beginning. You can already kind of tell where I'm going with that. Alright, 8 hydrocarbonic acid equals, so I double checked myself because I was like, I'm pretty sure it should be hydrocarbonic acid due to the word hydro right here plus name of non-metal, but I looked up online just to double check myself because I was like, and it said that this name is not recognized and that they do carbonic acid. So that's why I did the arrow to show my final answer of carbonic acid, H2CO3. And then hydrophosphoric acid, H3PO4. And then my last one is hydroselenic acid, H2SE. And I also wrote the rule again just to kind of help myself because I know it's a hydrogen plus a non-metal plus ic plus acid. All right. So, and then this one was asking for anions that end in 8. So then I did phosphate ion, PO4 to -3, carbonate, CrO4 to -2, nitrate, NO to -3, sulfate, SO4 to -2, and carbonate, CO3 to -2. And this is my last 5 examples right here. Anions ending in "ite," with the name of the anion ending in "us." So yes. So this is a nitrous acid, HNO2, sulfurous acid, H2SO3, sulfurous acid, H2SO3, phosphorus acid, H3PO3, and then hypochlorous acid, HClO, and then chlorous acid, HClO2, which again, I double checked myself because I was like, yeah, I double checked myself. But that's it, yeah.